This is notes number 4 for Mr. Sweeney's AP Physics C class, and today we're going to be talking about frictional force. Friction is the force that acts between two surfaces that opposes the motion of an object. And this force of friction depends on two factors. The first one being the texture of the surfaces, and the second one being the normal force holding the objects together. Bear in mind, normal force is not referring to gravitational force, normal force being the force that acts between the surface. Oftentimes equal to gravitational force, but not necessarily so. There are two different types of friction that we're going to speak about in this class. First one is static friction. That is the force of friction that one must overcome to move an object from rest. The second one we're going to speak about is kinetic friction. Kinetic friction is the force of friction that opposes an object once it is already moving. Static friction is how hard you push on something to get it to move. Kinetic friction, how hard you're pushing on it once it's moving. These are different. Static friction does not equal the force of kinetic friction. Static friction is always the stronger of two. So static friction is greater than kinetic friction. Static friction is greater than kinetic because when an object is stationary against another object, there is some degree of atomic bonding that happens between the two surfaces. So the two surfaces actually physically bond together. The extra force in static friction, as opposed to kinetic friction, is the extra force it takes to break these bonds. So we have a series of friction equations. The first one being the equation for static friction. Force of friction equals the coefficient of friction times the normal force. And we have the equation for kinetic friction. Kinetic friction, also shown as the F sub F, is our coefficient of kinetic friction times our normal force. Between the two coefficients, static versus kinetic, static will always be a higher number. Remember, all coefficients are just numbers. They don't have units associated with them. In these equations, we have our three symbols: force of friction, coefficient of friction, and the normal force. Here you can see the chart that we had on our Regents Physics. This will help you if you have to go through any examples that we do in CAS Learning. They show the two columns, the static and the kinetic friction. Let's do an example on this. A 7.8 kilogram box is being pulled across the floor by a rope that has a force upon it of 48 newtons, and this rope makes an angle of 49 degrees up from the horizontal. The kinetic force of friction on this, acting on this, is 11 newtons. What we want to know is, what is the coefficient of friction? To start this problem, we have this scenario: 48 newtons acting at 49 degrees up from the horizontal. This is acting neither horizontally nor vertically, so we need to break this force of 48 newtons into their horizontal and vertical components, and we do so using trig. The horizontal component is 31.5 newtons, and the vertical component is 36.2 newtons. When you make a free body diagram, you never use the 48 newtons, the angled vector. You always use the components. Remember, all components on a free body diagram must be acting vertically or must be acting parallel or perpendicular to the plane of motion. So, moving on from here, we have our two applied forces split into their vectors. We have other forces that are in play here. We have gravitational force acting on the object. This object has a mass of 7.8 kilograms, And the force, the acceleration due to gravity, is pulling down on this mass 9.8 meters per second squared. This allows us to calculate the force of gravity acting on this object, and that is 76.5 newtons, and that's pointing downwards. So we have 76.5 newtons pointing downwards. The problem also gave us 11 newtons of frictional force acting on it, and we haven't calculated, but we know that there exists some normal force acting between the box and the surface. Note that the force of gravity here, 76.5 newtons, is not the normal force because we have some upward component. The normal force just makes up the difference in the vertical direction. So it's 76.5 newtons downwards from gravity, 36.2 newtons upwards from our applied force, and our normal force is just the difference between those two. So 76.5 newtons minus 36.2 newtons gives us a normal force of 40.3 newtons. Our free body diagram allowed us to figure out exactly what our normal force was. That was the reason for this. And now we can go back to our friction equation. It says force of friction equals our coefficient of friction times normal force. So that's 11 newtons. That was given to us in the problem. And we figured out that our normal force is 40.3 newtons. 11 divided by 40.3 is 0.273, and that is unitless because it is a coefficient. That wraps it up for frictional force.